Good evening, guys. Thank you very much for attending this session today. This is Dev204, Debugging Modern Applications. I know the monitor outside said monitoring modern applications, so we're going to switch this up a little bit on you guys. And as Alan was telling me earlier, we're competing against free beer and snacks, so we greatly appreciate you guys being here. All right, so let's get started with what to expect from this session. I'll quickly introduce myself. My name is Abhishek Singh. I'm the Senior Manager for Product Management for AWS X-Ray and AWS Elastic Beanstalk. And I'll let Alan quickly introduce himself.
I'm Alan Nicolay with Chick-fil-A. I'm an enterprise architect from Atlanta, Georgia.
So today, what we're going to cover in this session is give you guys a quick overview of X-Ray, talk a little bit about the history, why we built the product. We launched X-Ray last year at reInvent, so it's been about 12 months since we launched it. We'll talk about concepts, just so that you guys have a good overview of what the terminology is, what you should be going and searching for if you want to learn more about X-Ray. Since this is an introductory session, I will not go into a lot of details. We have a deep dive session that's scheduled for Thursday that will go into much more detail. So if you guys are interested in a deep dive, we're going to cover that on Thursday. We're also going to look at the use cases for X-Ray, why you should be using X-Ray. We'll talk about getting started so that you can quickly, after the session, maybe tomorrow, maybe on your flight back home, try a few sample apps, get your own apps instrumented with X-Ray. We'll talk about Chick-fil-A's story of how they started using X-Ray right after reInvent last year, and how it's helped them and what they've learned along the way. And then finally, we'll do a Q&A so that we can answer any questions that we may not have answered as part of the presentation. So as I mentioned, we switched this a little bit from monitoring to debugging. Anybody who's done debugging of applications, specifically applications that use service-oriented architectures or operate on multiple fleets, if you will, you've known that it's essentially not the same as traditional debugging. So in traditional debugging, the developer starts with writing some local tests. You've got data that goes into logs. Then the developer searches through those logs to find any issues, going back again to adding breakpoints when you're debugging, and then essentially re-adding log points. So what you're doing as part of this process or this cycle is essentially, as you find issues, you add additional log statements that essentially enable you to find those issues if they ever happen in the future. So the process of using logs for debugging essentially implies that the issues that you're logging are issues that you already know about. So how do you find issues that you don't know about? All of this, I should say, is further complicated by the shift from monolithic architectures to service-oriented architectures. So previously, you had something that had logs on a single machine, maybe a set of machines going into a single place, much easier to search and find. Now you've got microservices, serverless, service-oriented architectures, where you've got possibly hundreds, even thousands of different pieces sending logs individually to different places. And now you don't have a mechanism to go and collate all of this and really understand an end-to-end view of what's going on. So I said that I would talk a little bit about the history of why we built X-Ray. So when I started with AWS in 2013, I led product for Elastic Beanstalk, which is our platform as a service offering. After a couple of years, about 2015, we started getting a lot of feedback from our customers who are using service-oriented architectures that it's really difficult to understand what's going on in this mesh of applications or services. And the feedback really was clear that the traditional process of debugging didn't scale well for these type of applications. And customers kept telling me that it was very tedious, it was repetitive. To a certain extent, developers found it boring, and it took a lot of time, so it was time-consuming. And so in addition to deploying and managing service-oriented applications or microservices applications, some of that which is solved by AWS services such as Beanstalk, Lambda for serverless, EC2 container service for containers, CloudFormation for managing infrastructure as code, it was still difficult prior to X-Ray to really understand your cross-service interactions. The varying log formats across different services, so essentially developers writing services in different programming languages using different formats for logs, made it even harder. Additionally, collecting, aggregating, and collating logs at large scale was very difficult and a challenge. So that's part of the reason why we took today's log-centric approach, where you essentially have a user talking to a host of services, individual services logging to individual log storage systems, if you will, to switch it to a user-centric approach. The whole purpose of X-Ray was really to give developers a user-centric view and enable them to answer questions without actually instrumenting or without actually writing logs or metrics for them prior to the application being run in production. So what X-Ray really helps with is identifying performance bottlenecks in your application. So once you've instrumented your application, X-Ray automatically collects metadata about remote calls, and you can see which calls are, in essence, causing bottlenecks. So for example, slow database queries. You can very easily identify those if you've instrumented your application with X-Ray. The second point that X-Ray helps with is pinpointing issues to specific services in your application. Additionally, X-Ray also logs errors, including the full stack trace, so that you can actually go in when you have exceptions, see the exact line of code where you ran or where that exception was thrown. And finally, I would say the most important point about X-Ray is that everything it does is very focused on enabling the developer to identify the user impact of any issue in your system. So for example, if you were a developer and somebody came up to you and said, hey, I'm running, this metric is at 90%. With X-Ray, you can go back and say, none of my users are impacted, so I'm doing a great job on utilization, right? So a metric being at 90% does not necessarily mean it's a bad thing. It's only a bad thing if your users are impacted. And X-Ray really lets you answer those questions. So before we dive into sort of the details of X-Ray, I want to cover a few concepts so that we're on the same page in terms of terminology. So with X-Ray, we've got, in essence, what I have here is a three-tier service, if you will. So there's a front end, an API. I have Dynamo as the backend or the database. And I'm using a queue. And what X-Ray does is it starts with this notion of a trace. A trace represents an end-to-end transaction as seen from the user's point of view. The next concept in X-Ray is a notion of segments. What segments represent is the entire set of data that's collected as part of a single service. So in this case, I have a segment from my front end, and I have a segment from my API. The third thing is a notion of subsegments. What subsegments represent is remote calls or in-process profiling, if you will. So if you wrap a function with X-Ray, which you want to time, so assume you have a function that generates a random number, for example, and you want to time that function. You can wrap an X-Ray call around it and essentially get that timing information. And that timing information is captured in X-Ray as a subsegment. In this case, I have a remote call from the front end to the API, which is a subsegment. And then I have two remote calls that go from my API to the DynamoDB table, as well as the Amazon SQS queue. They are both representing subsegments. So the easiest way to remember is subsegments is the smallest, in essence, unit of time that is being captured by X-Ray that then becomes collated or stitched together into segments, and then segments get stitched together into traces. So I've covered the top three concepts here. I'm going to talk about a few others. X-Ray has a notion of annotations. Now, annotations are really important in that annotations allow you to add business data to traces. A good use case for annotation is, imagine your Amazon video. And when a user logs in, you essentially attach the user ID to the trace. Now you're launching, let's assume a new channel. Let's call it HBO. When you launch that channel, you start getting a bunch of customer feedback where customers are complaining, hey, I've got problems going and viewing HBO. Since you have the annotations with the user ID, you can actually go into X-Ray and say, for all users that have channel as HBO, show me the user IDs. And you can actually track that. And you can get a top K list of all your users that are being impacted and what the impact on each individual user is. So you're essentially getting high cardinality metrics, if you will, to simplify it a little bit, by using annotations and attaching business data to X-Ray. Metadata, on the other hand, is similar to annotation, except that it cannot be used for filtering or searching for traces. So metadata is more about capturing, if you will, small snippets of code. It might be the output of an API, things that you want to look at to get additional context on a trace. The next concept is that of errors. So as I mentioned, X-Ray captures exceptions today, including the stack trace, so that you know exactly where the exception happened. So that's where error comes in. And then the final notion we have is that of sampling. In X-Ray, sampling is optional. Sampling is done in two ways. You have a rate-based sampling, so you can go in and say, I want to sample everything at X percentage. Or you can set a minimum rate and say, I want to capture at least one transaction per second, and above that, I want to sample at 5%. Now, why is it important to have both a rate as well as a fixed sampling rate, if you will? So imagine you've got a system where you've got 1 million transactions that come in from US, and you've got 5 transactions that come in from, let's assume, Central Asia. Now, if you were to sample both of those at 5%, what you would get is the American transactions would completely swamp out the transactions from Central Asia. Because in X-Ray you can set that minimal rate and you can do it at a per URL or a per endpoint or a per service basis, you can actually say that I want to sample transactions from Central Asia at 100% versus the American transactions at 5%. Similarly, you can go in and say, hey, my payments API is really important, and I want to capture everything from there at 100%, versus my gets on my front end is not really that important. I can sample that much more aggressively. So there's a whole bunch of different configuration options that you can do with sampling in X-Ray. So we're quickly going to hop into use cases, and I'm going to try to be brave here and actually do this live as a demo instead of my slides. So let's see if I can pull this off. All right, let's switch it over. See if I can make this. I'm going to try and, I'm going to try and, oops. There we go. Thank you very much. Let's try and make this bigger. All right, perfect. So what I have here is a very simple application. This is a 3-tier application. It's our sample application, actually available on GitHub if you want to go run it. It does something very simple. You can go sign up. You can put in a name, an email address, and then choose if you're interested in a preview. You can click sign up. And what that does is essentially store the email address and this data in a DynamoDB table, and then uses SNS to send notifications. Now, this application is instrumented with X-Ray, so let's go look at what it looks like in X-Ray. So what you're seeing here, essentially, in X-Ray is what we refer to as a service graph. And what the service graph enables you to do is really understand the architecture of your application, right? So I've got a service here called frontend that's talking to my API, which is then talking to DynamoDB and talking to SNS. So essentially, I get to understand what services are depending on which services, what are my upstreams, my downstreams, for example. The other thing that you do from the service graph is essentially you get a notion of health, if you will, of each individual service. So as you can see, On the service graph, my front end has a little bit of orange and red. So I've got some errors and issues going on there. My API seems to have a larger percentage. Seems to follow what Dynamo is showing me. So in Dynamo, I've got some purple, which is throttling. And then I've got some orange, which is client-side errors. So I'll pull up this map legend so that you guys can see this. So green is essentially success or OK. Purple is throttling. Errors are 400 HTTP 400 status codes, so client-side errors. And then false are 500s. So in this case, the first use case, as I mentioned, of X-Ray is really understanding what your service or your application looks like. The second use case is diving in either from a performance perspective or diving in from an errors or a user impact perspective. So let's actually go see the user impact perspective. So I'm just going to go and do view traces. And what X-Ray just did for me was essentially go in and find all the transactions or traces that I've captured for that particular front end. I'm going to switch this to status code. And what you can see here very quickly is that I've got about, a little over 4% of my users impacted by 400s, and then almost 1% of my users impacted by 500s. So again, very quickly, I know what the user impact is of these issues in my application. Now, once I know that I have these errors, let's actually start debugging these errors and see what's going on and get to the root cause and actually figure it out. So what I can do is just click on 500. And what that did was essentially, it's updating this filter expression that I've highlighted over there. And I'll pull up the screen here just to give you guys a quick overview of the things you can filter by. So in X-Ray, you can do things like you can search for the global response time. So you can say, show me all transactions or all requests that took longer than a certain amount of time. We have a notion of response time and duration to enable you to encode both synchronous and asynchronous requests. Similarly, we have the ability to search through the graph, if you will. So you can run queries by saying, show me all requests that went through a particular service, in this case, api.example.com, that had a fault on that particular remote call and had a response time of greater than 2.5 seconds just for that service. This is not the end-to-end transaction. It's just on that service. Additionally, you can search by annotations, which I mentioned earlier. You can similarly run queries on edges. So these are directional connections between services. In this case, I've got API talking to my backend. And then I'm saying, show me all requests where the API talked to the backend and that particular remote call had a fault in them. I can additionally filter by different properties of the HTTP response or transaction. I have some shorthands, and then I have a full list of different properties I can search by. So I'm not going to go into each one of these. I'll let you guys do a little bit of reading if you're interested to get more information here. So now that I've found all my requests that ended up in 500s, let's actually go figure out why I'm getting those 500s. So I'm actually going to click on one of these transactions. And when I click on this, can everybody see this at the back, or should I make this a little bigger? OK. Better? Awesome. All right, so what I have here essentially is I have a request that went from my front end, which was a post. Then it went to the API, so we hop over to a different environment. So it could be a different container. It could be a different Lambda function. It could be a microservice that's running in your data center, for example. It could be something that's running on a developer desktop. We don't really care. As long as the context is maintained, you can actually track that through X-Ray. And then as part of the post on the API, I made a call to DynamoDB. And as I can see here, that's where the error happens and essentially propagates up the stack. So if I hover over the error, it's telling me that it's a remote fault caused by provision throughput exceeded exception. So basically, it's telling me I do not have my DynamoDB table configured appropriately, specifically the write capacity here. So I can actually click on this. I get the full exception, as I mentioned. So there's the full message here. And then I have a full stack trace, which actually tells me the exact line of code where this happened. Now, in this case, it's not really an application or a code issue. It's really an issue with me provisioning my DynamoDB table. So I can simply ignore this, and I can look at resources. And on the resources tab, what we're showing you essentially is the table name, the region, the number of retries. So in this case, the SDKs actually retried 10 times before they failed. So you can actually copy this table name into DynamoDB, the console, and increase the provision throughput for this and fix this issue. So very quickly, I know that, OK, that 500 happened because of DynamoDB. I can go in here and say that happened because of DynamoDB. And very quickly, sorry, I'll hop back in here. Let's do status code 500. And so very quickly, if I go through a few of these, I realize that it's a DynamoDB provision throughput issue. I go provision my table, make it a little larger. Everything starts working just fine. The second issue that I had was a 404. So I'm just going to type in a 404. Since these are URL-based, I'm just going to switch to URL. And very quickly, what I see is 100% of my transactions or requests that failed were because of my blog URL not working. So let's actually go prove that very quickly. So my blog URL is broken, right? So I can go fix that very quickly. The next thing was a 409, so let's go look at that. And so from a 409 perspective, let's hop into one of these and see what's going on here. So similarly, I seem to have something going on DynamoDB. In this case, it's a remote fault caused by conditional check failure. So if I hop on this, I know exactly what line of code my issue happened. So having written this code, I know if I go look at that line of code, it's essentially a conditional write to DynamoDB that is checking for the email address. And if the email address is duplicated, that's when you get this error. So having said that, I have a hypothesis of why I'm getting these errors. And the issue is, my hypothesis is someone's sending me invalid input, which is trying to sign up with the same email address over and over again. So let's actually go see what the email address is, because I was smart enough to annotate these. So I can go look at the annotation. And the email address in this case is demo@example.com. So let's go back to traces. I can go through each one of these traces individually to ensure that each one of them have the annotation demo@example.com. Or I can do something interesting by going to group by. And what group by automatically does is it collects all the annotations that you have, and it puts them here. So I can get a top K list. So if I click on this, and my hypothesis is correct, I should see a set of email addresses that represent 100% of these transactions. And so there you go. Very quickly, I've gone from looking at my code, looking at the error that happened, to having a hypothesis as to why that's happening, and then proving that this is a valid client-side error or a client-side issue, and I don't need to worry about this. So that's essentially a quick overview of what X-Ray enables you to do. One of the things I do want to highlight is this response distribution area that you're seeing here. So if I click on this, I see that my service has a really good response distribution, but I have a bunch of outliers, right? And so this happens all the time when you have slow database queries, for example, or you've got cache misses when you don't expect them. So I can actually just click on that and do view traces. And what X-Ray does is automatically generates the filter expression for you so that you get a list of transactions down here that meet that criteria, right? So these are all my slow transactions. And I can sort them and go through them and very quickly have hypotheses or even go back to root cause of why these requests are slow. So just wanted to give you guys that last bit before I switch back over to my deck. All right, so let's hop back over here. Perfect. So we talked through the visualized service call graph. We talked through identifying impact. We talked through pinpointing issues, which is the 500s. We looked at the actual exceptions and the stack traces so that you can go back to code. We talked about identifying performance bottlenecks. So the last thing I want to cover here that was not in my demo is X-Ray essentially is already available for Lambda. So for those of you that are working with serverless or Lambda, X-Ray is automatically, in essence, enabled for your Lambda functions. The value of using X-Ray for Lambda functions is that it does a few different things for you. So what you're seeing on the screen here, the two highlighted, if you will, lines. The first line is the actual Lambda service. So this is something that you cannot get today, besides from X-Ray. And it's telling you how long it took. And the difference between the first line and the start of the first line, I should say, and the start of the second highlighted line is essentially your cold start time, or the amount of time it takes for Lambda to bring up a container the first time a request hits. The second highlighted line is the initialization time. So this is the amount of time spent in your init function that you've provided for your function. So again, for Lambda, you can very quickly understand the performance characteristics by using X-Ray. Similarly, if we look at an existing container, you see that it's much faster and you don't incur either the cold start time or the initialization time because of container reuse. You also have the same capabilities as far as it goes to exceptions. So in this case, I have an exception on S3. And if I hover over it and click on it, I can actually see the real exception along with the stack trace again. So now that I've covered that, I'm going to hop into some advanced use cases. So the first use case of X-Ray that not a lot of people know about is that you can use X-Ray off cloud. What I mean by that is you can use X-Ray to instrument applications on premises. You can do it in development on your developer desktop. You can do it on other clouds. Doesn't really matter where you run X-Ray, as long as the machine that's running X-Ray or the application can talk to the X-Ray endpoint, and it has the credentials to authenticate with that endpoint. The next use case is custom payloads. So today we have a bunch of SDKs that allow you to send data into X-Ray. However, we also document our APIs, and we document the actual data format that you need to send data into X-Ray with. So for example, if you have a workflow that you want to time, you can use X-Ray to time that. It's not just for applications. You can really time anything with X-Ray as long as you have the context being propagated and the correlations between different activities being maintained. The next advanced use case is deep linking. So all the views in the X-Ray console are deep linkable. What that means is if you're using a tool like Kibana, where you've got logs that you're logging your trace IDs into, you can actually create hyperlinks directly into X-Ray in your Kibana dashboard. So that makes it super easy for developers to look at metrics or log lines and then go back and jump into X-Ray and look at those request IDs very quickly. I covered filter expressions in the quick demo that I did, but essentially the ability to quickly filter and find the needles in the haystack, if you will, is another use case. Another thing that you can do using the API and filter expressions is that you can build custom dashboards. You can do custom alerting that is very specific to your use case. So those are some of the things that I didn't cover previously, but it's an advanced use case that you can code yourself. And finally, you can write custom applications. So everything that I showed you today with the web console is all using our public APIs. So you can actually build the service map yourself if you wanted to use a different visualization. You can build a timeline. X-Ray gives you the raw data for all of that so that you can build custom apps, custom dashboards. For those of you that are interested in custom applications or learning more about X-Ray, we do have a deep dive session that's coming up on Thursday. I have the information there, so feel free to attend that. David Nunnerly, our senior manager for software development, will be presenting. Let's quickly hop into how X-Ray works. So I'll cover the different components of X-Ray. The first component of X-Ray that developers interact with is the SDK. The SDK is available for Java, .NET, Python, Go, and Node.js. All the SDKs except for .NET are open sourced, so the code is available on GitHub. We're going to open source the .NET one fairly shortly. What the SDKs do essentially is add filters to automatically capture metadata for calls that your application is making, or remote calls. So things like calls to AWS services, non-AWS services over HTTP or HTTPS. One of the other use cases I should mention about X-Ray is that you can actually use it to get response timing or SLA information for third-party APIs that you're using, right? So if you're talking to the APIs over HTTP or HTTPS, you can get a really nice response distribution and then talk to that vendor and hold them to the SLAs that they say that they're providing to you. Same thing goes for AWS services, by the way. We have filters available for databases, so MySQL, Postgres, and DynamoDB, and then queues in Amazon SQS. The second piece of the X-Ray service is the X-Ray daemon. The X-Ray daemon is something that's optional. We highly recommend it because it goes in concert with our SDKs. And it does a few different things for you. One is it takes care of all the authentication with the AWS service backend. It takes care of buffering the data for you. And then it takes care of sending all of that data to the backend in an asynchronous way so that your application's latencies are not impacted by running X-Ray in production. The daemon itself is available for various operating systems. It's pre-installed on Lambda. And as I mentioned previously, it can be run anywhere as long as you have access to the API endpoint and the credentials for AWS. And the final piece, or the third piece I should say, is the service itself. The way the service works is it collects data from all the various microservices that are sending data to the backend. It, in essence, acts as a funnel, collecting all of that data. And then it stitches individual transactions into what we call traces. So what's going on, essentially, if I were to use the terminology we talked about earlier, is essentially services are sending segments and subsegments to the backend. The backend then looks across all the segments and subsegments that have been sent, and then it starts stitching them together into traces. Finally, what it does is it outputs the service map. What the service map is an aggregation over a period of time of all your transactions. So the way we figured out that the front end is talking to the API, it's talking to Dynamo and SNS, is essentially by looking at your transactions in an automated fashion and then aggregating them over time so that we can give you this quick visualization, enabling you to, again, dive deeper and find those needles in the haystack that you're looking for. The last piece I want to talk about is trace ID and propagation. Now, this is important because this is what enables X-Ray to actually create the end-to-end view. So this is the application that we saw. So what I have here is a front end, an API. I've got a database. I've got a third-party API. And then I've got a worker, which is talking or essentially picking up work from a queue. So what happens is the SDK starts off by generating a segment, and it creates an ID. It then propagates that data over the wire to your API with some additional information. The API then generates a segment for itself. It propagates some data downstream. In this case, the blue circles or the blue items are not instrumented by X-Ray, so these are inferred. Again, I have a transaction that's going to a third-party API, which is not instrumented. However, that information is sent over the wire, so that if at some point in the future the third-party API or the database becomes instrumented, it can start participating in the tracing. And then finally, I have that call to the queue. Then my worker picks up the message from the queue, so it's acting up and sending a segment. And finally, we get that query, if you will, to the queue. So that propagation essentially is what enables us to build a singular trace by using the transaction IDs and the correlation or the parent IDs that you have there. Here's a quick workflow just to give you a sense of how X-Ray works. So you see the application and the X-Ray SDK. You see the EC2 role that's used to authenticate. There's the daemon that's sending data into the API over HTTPS. Similarly, you've got the notion of AWS and then off cloud. And then the DevOps team or the developers access this through the X-Ray console. So I talked about sampling. Here's just an example of the configuration, so I'm going to quickly hop over this. We'll quickly jump into the APIs. So the APIs essentially provide you the capabilities to do everything that we've talked about thus far. So send data, filter data, retrieve data. All the raw data that's stored in X-Ray is available through the API. Additionally, the APIs enable you to build your own analysis or data analysis applications. We have 4 different APIs. I won't get into the details here. You guys can attend the deep dive session if you want to get into the details. But essentially, there's a put, a get for the traces, and a get for the service graph. And then we have get trace summaries, which enables you to do the filtering. Here's an example of the raw data that's sent to the X-Ray service. So you can think of this as a structured log. And we'll hop into getting started. So again, I will not stay on this a lot long, because you guys can read this in the documentation. But you can install the agent on EC2. Similarly, you can install it on Windows using a shell script or PowerShell script. You can do this on containers by using our binary. In terms of instrumentation, I want to cover this slide. So all the lines in blue are essentially what you have to write to instrument your application to get started with X-Ray. What I have there is essentially pulling in the SDK for X-Ray, initializing a few things, setting a few optional configurations, and then starting and ending my express handler, if you will. And this is roughly what you need to do regardless of the size of your application. For Java, for example, you load in a servlet filter. I know Alan's going to talk about that a little bit. So I'll hand it over to Alan.
Thanks, Abhishek. So my name is Alan, and I work for Chick-fil-A. And let me get to this. And yes, that cow's wearing X-ray glasses. Just for this presentation, though. So if you're not familiar with Chick-fil-A, we're a quick service restaurant. We sell a lot of chicken. And we have about 2,000 locations. And our locations are a little bit different than a normal franchise. Chick-fil-A builds out the restaurant, puts all the IT and the technology in the restaurants. And then we get what we call an operator to run that Chick-fil-A. And it's really a small business. Maybe about 120 employees that are running each one of those Chick-fil-A's. And almost all of our operators run one Chick-fil-A, so they're there on a very, typically daily basis. And a very small number of them can run up to three Chick-fil-A's. But that's kind of a little bit of how Chick-fil-A works. And so I'll tell you a little bit about kind of a journey we started about 1.5 years ago. And really around starting to use cloud, changing our organization a little bit to use DevOps. So we created a project, and it was our first DevOps team that we created, and also really come from an architecture perspective, embracing microservices. So 3 huge buzzwords, check, check, check. And from a use case perspective, for our operators, we're creating a mobile app for Android and iOS that we call Chick-fil-A Now. And so it shows operators and their management team what's going on in their restaurant right now from a data perspective. So for example, you can look and see your sales down to the minute right now, but also compare them to the same day last week or compare them to the same day last year. To see how are we doing, not just raw data, but data that's kind of actionable. Labor data, maybe truck tracking data, hey, your truck's 30 minutes away. Maybe data around all your different employees, all the contact information. So it kind of fits really well with microservices because it's a whole bunch of different kind of unique data sets. And some of those data sets are nice cloud native APIs. Some of them hit legacy systems. Some of them reached all the way back across a bunch of awful networks into our store and pulled data out. And so there's the potential for all kinds of fun performance problems to debug across there. And so from a technology perspective, and just kind of tied to the skill set of the team, but Java and Spring Boot deployed on top of Elastic Beanstalk. And a lot of our backend data stored in DynamoDB, and we also use quite a bit of Lambda. And so We jumped in with that one, had a lot of fun, and the results, we had a lot of success. I mean, success where it really matters. We impacted our operators. It was very positively received. We got an instant, massive pipeline of new features, which always is a gauge of success. Definitely DevOps from our perspective. We got out of our cubes. We got out of our offices, co-located in the same space, worked really around 2-week sprints. That was actually a whole lot of fun and something we're propagating through our organization. Obviously, the cloud is pretty impactful. And microservices were definitely awesome from our side of things. But while they solve a lot of problems and break up the monolith, they add extra complexity too, especially around debugging. We did a lot of log-based debugging, really that he described, especially with microservices spread across multiple accounts, even reaching back into our data center. It was kind of annoying, kind of slow, not very much fun on that part. And so it really kind of, after we delivered this, we really said we need this application level tracing. We need this application performance monitoring. And so we kind of started digging in and looking at a lot of different options. And we were looking at different options right around when X-Ray came out at reInvent last year and said, you know what, they have the core feature set that we're looking for. We jumped on their beta and we've been using it for a year. And so from one of the questions that kind of spawned for us was think about kind of standards and even enterprise excellence in the organization of you couldn't imagine not monitoring your CPU for EC2 instances or that sort of stuff, but is tracing your application, should that be something that you have as a standard within your organization? And after the last year, it's definitely obvious that we want anything we build, anything we deploy, whether it be a little Lambda or an API, there's no reason not to turn it on. And so we're looking saying, why wouldn't we make this a standard, or what would we need to make it a standard? It really comes to 3 things. One is pricing. And it's kind of a big deal because before X-Ray, when we were looking at a lot of different options, it was costing more to monitor the app than the underlying EC2 compute, which just drives me nuts. And so I want cloud pricing. I want to be able to pay for what I use. Tracing as a service, we have these small DevOps teams, and we don't want them to deal with infrastructure. I want a service to provide this is a big deal. Check on both of those for X-Ray, but also the other one is ease of integration. If I want something to be a standard, hey, we have to be able to afford it. It has to preferably be a service, and it has to be able to be really easy to integrate. And especially with Spring, it was really easy. I mean, and Beanstalk, you're effectively checking a checkbox and adding a config to each POM, and have some basic interceptors for traffic coming in that you can set your annotations and decorate. And then you have a pretty easy way of adding your custom measurements. And so for us, it was really straightforward. It met our needs. And that's really why we're using X-Ray there. But the other one is just kind of some of the bigger impact. So changes to our team. There's a lot of times, I don't know if you guys ever do this, where there's a little bit of ugly code back there. And you have a little bit of performance problem, and you're like, I'm going to go fix that. I've been meaning to refactor that. You might spend even an hour cleaning something up that's been bothering you. And it turns out ugly code performs really well sometimes. Compilers do a great job of optimizing some ugly code that you have. And so sometimes you just really need to be able to get in there like I was looking at, take 2 minutes and see what's really my source of the problem. And for us, where we have some APIs that reach all the way back to a restaurant, maybe over a slower network, if you have an API performing slowly, it's easy to also to blame it on, it must be the callback to the restaurant. Like, that one doesn't even hit the restaurant. We can't blame it on that one. But a lot of times, 2 minutes saves hours of debugging, kind of boring time there. The other one this is kind of weird, but encourages curiosity. I like to be able to explore that data. If it's log-based, nobody's curious about log-based data. Unless there's somebody calling in a help desk ticket saying, hey, we're having performance problems, you're not going to really explore log-based data. And so the UI allows you to dig around, and it's good enough that it's not just an architect or a developer. A product owner can also get in there and look and see, hey, what's going on? And we'll dig into have a little demo afterwards. And I just got a little curious and wanted to see what I could find. And found some kind of interesting stuff. I love my graphical peer review just to see what services you're using. If that graph looks horribly messy, we want to blame it on X-Ray and go, X-Ray, you made a terrible graph. But usually it's more of an architectural problem. And just more data-driven decision making, which kind of jumps over to kind of the enables analytics. If we're running in 2-week sprints from an agile perspective, the push is always for getting new features and new functionality out. And so there's always this little bit of a battle. When do you say, hey, we need to go fix some cracks in the foundation? And if I can have data to show, hey, we have this performance problem here, it's affecting 5% of our users. That's real data that you can use to drive changes and that work getting actually put into a sprint. And the other one for us is we're kind of moving to a kind of an SRE kind of model and looking to say, how do I measure performance on our APIs? And averages can be really deceptive sometimes. You look at averages, and the averages might include your health check. It's returning in 1 millisecond every single time. Or you may have a ton of endpoint calls on this microservice that are really fast, and 5% of them are kind of slow, and it just gets lost in the average. And so we want to be able to say, on a per endpoint basis, what's the performance we expect? And be able to actually measure those, track those over time, and be able to say, hey, I want to have this much of my traffic underneath this certain threshold. Not on just a whole server level, but on a specific endpoint level. I think that's a pretty important piece there. And so I'm going to, actually, I wasn't as brave as him. I'm not going to do the real one. I'm going to do my slides. So I have a use case here. So this is our kind of a big piece. The squares are microservices. The kind of pink ovals are external calls. Some of them are hitting other AWS accounts. Some of them are hitting our managed data center. And a lot of the other green circles are DynamoDB. But I want to jump in. We're going to drill down on one of them here, and it's our contacts API. And so number one is the main API. On the top right, it hits contacts is kind of interesting because a store will have about 120 contacts. And there's a certain amount of churn that's always happening. And so before this, the operators would all, and their management team, they'd get a new team member, they'd add them to their phone. If they wanted to call somebody or text somebody, they had to keep it there. And so by having contacts here, we're reaching out to a legacy system to be able to pull those contact information. We actually allow them in the app to take pictures of their team member, so it'll show up in their contact. We store those in S3, which is the upper right-hand circle. And we also allow like a little bit of metadata related to those contacts, like what's your preference? Do you prefer to be texted or emailed or called? And so number two on this list is our that external call. And that's going back to a legacy system. It's a lot slower. So when we kind of moved fast initially with this, what happens sometimes is we'd be able to put an API in front of a legacy system, knowing 6 months from now, we want to maybe have that data streaming up to the cloud, maybe to Dynamo, and then it gets a whole lot faster. So right now, it might be a little bit slower, but knowing it's going to get faster, it's better to provide the data a little bit slower now and make it faster later. But if you look at number 3 on that graph, the vast majority of those are really fast, but if I select the ones that are slow and click the button on View Traces with number 4, I drill down to some of them that are slow. And if you looked earlier, all those circles were green. Everything's looking great. And so when you drill down in the details, you'll see sometimes, even though it's green, it's not really great. And so you look at the green circle I have on here. The average for these calls is about 3 or 4 seconds. Not great for most things, but for this specific call, knowing we're going to optimize it later once we get the data streaming out of our data center, that's fine. But in the red circle, you see some of them are taking over 10 seconds, which is definitely not good. And so I drill down on that trace, and it's really interesting to see the green rectangle here, all millisecond calls, bunch of calls out to other APIs and other accounts, some Dynamo calls that are all milliseconds. But then in the red rectangle, you can really quickly see, hey, this is what's taking all our time. And notice it all kind of looks the same, all 3 of them there. And so when I actually drill down on those or hover over that mark, I realize we're making the same call 3 times, but each restaurant has a different restaurant location number. And by looking at the metadata there, I can see there's a different location number with each one of those calls. At first, I looked at this, and I was just exploring around while making this presentation, and I found this, and I thought, what in the world? What's going on here? See the data, and I realized, almost all of our Chick-fil-A operators have one restaurant. But a very small percentage of them, out of 2,000, probably less than 50, have 3 restaurants. And I'm betting when they tested all of this, they tested with one restaurant and never tested the performance on all 3. And so I went and talked to the developer afterwards. He looked at it and said, we had this in a few of our APIs. We must have missed this one. It's a really easy fix. Either we're going to look at the API and see if we can pass it 3 restaurants at once, or we'll multi-thread this and hit all 3 at once, and we're fine. And, but then it led to further discussion on, well, how do we miss this in testing? Do we not have any integration tests or performance tests that use 3 restaurants? And not only that, but this is taking 10 or 12 seconds here for our operators that run 3 restaurants. These guys are like the busiest operators of anybody. These are the guys I really don't want to slow down. And so how did we miss that? Did we not think about those guys in our test data? So not only is it going to get fixed, but it's also going to change how we test. And the cool thing on this is that it took no time to drill down and find that. These operators are really busy, and most of the time they're not going to call the help desk and go, hey, this one page loads slow. They're just going to like, OK, it loaded and move along. So this kind of proactively being able to be curious and dig into your data and find it is really valuable, because a lot of times the fix is really, really simple. And I threw one here in the end that's what it looks like when there's only one, an operator that only has one restaurant. It's only making one call is fine. But it also kind of one of the fun things I like about X-Ray here is being able to see the speed of some of the other services in AWS. And so if you look next to my little heart there, DynamoDB took 5 milliseconds to return. And so it's kind of interesting when you start seeing how long things are really taking. 5 milliseconds. You might, from a code perspective, you might go, you know what? I can make a couple database calls as part of my transaction. That's not a big deal, because they're taking 5 milliseconds. And so I just thought it was kind of ridiculous that Dynamo got it down to 5 milliseconds. It's a single record get. But if you see a DynamoDB developer, give them a hug today. So with that, my last slide here, I always like to end with Truett Cathy was the original founder, or the founder of Chick-fil-A. And he has a, don't miss the importance of making fun a priority, as a quote of his. And we have a lot of fun at Chick-fil-A, building, creating, impacting people, impacting the business. And especially in IT, we look and say I want to focus on that building and creating, not on a lot of the other boring things. And so if I spend a lot of times debugging, it's not going to be as fun. From a DevOps perspective, you're going to have to do ops. But how small can I make it? How efficient can I make it? We have this thing we always say, how do you feel at the end of the day? When you're leaving on a normal day at 5 o'clock, how many times are you leaving going, that was a good day. That was a lot of fun. If you spend your day going through logs and digging through a performance problem, you're probably not going to say that. If you had a performance problem, but in a half hour identified it, got to the source of it, and fixed it, and you did that a couple times and then got onto something else that was far more interesting or impactful, you can easily say, I had a good day. That was a lot of fun. And so we're trying to have fun, especially in IT. DevOps was a cool part of that. We all sat together and had a great time and created and developed. And the higher level services in the cloud, like Beanstalk and like DynamoDB and like X-Ray, allow us to have a lot more fun and a bigger impact. So if you're ever passing through Atlanta or you live there, my LinkedIn's on here. Poke me. I'm always up for a good conversation. Thank you.
Perfect. So I'm going to cover a few pieces of additional information. For those that have stayed till now, we have some T-shirts up front at the end. So if you want some T-shirts, you may want to hang around. Otherwise, I know beer is more interesting of a choice than T-shirts. So let's quickly cover pricing. I wanted to make sure we covered this. So X-Ray does have a free tier. The first 100,000 traces that you record are free. So that essentially allows you to record about one request, a little over one request a minute for free forever. The first 1,000,000 transactions or traces that you search or retrieve are free. Beyond that, it's fairly nominal. So it's $5 for every 1,000,000 transactions that you record, and 50 cents for every 1,000,000 transactions that you retrieve or you search for in the system. Want to leave you guys with this slide. It's got a bunch of helpful links to our documentation, to our samples. So feel free to take any pictures that you guys want. After this, I have the Q&A slide, so I'm not going to go to that. I will just hop into Q&A. We've got about 5 minutes here. So if anybody has any questions, we've got a couple of microphones up here. If you come and ask any questions, you'll get the T-shirts before everybody else does. So we'll try and incentivize you to ask questions. So happy to take any questions you may have right now. Go ahead. So the question was, is X-Ray HIPAA eligible? So today, X-Ray is not certified for HIPAA. We are working on that. So if you follow our Jeff Barr's blog post, you should see that coming up in the next few months. Go ahead. So the question was, are you considering PHP support? The answer is absolutely yes. That also should be available in the next few months. Go ahead.
Is this available in GovCloud?
X-Ray today is not available in GovCloud. That is also on our roadmap. So okay. Again, thank you for the question. So, guys, as you're asking questions, feel free to grab a T-shirt from up here. Go ahead.
This is applicable to Alan as well. So did you guys replace any of your logging or reduce your logging after going to X-Ray because maybe it was redundant? So what are some of the practices between the logging that you have to do application level as well as making use of X-Ray?
We did reduce logging. Sometimes when you're debugging a performance problem, you end up creating a lot of extra logging that's sometimes a little bit of noise. And so we're kind of leery of creating a lot of noise in our logs. And so there's specific spots where we log, but if I'm not going to the logs right away and adding a bunch of extra noise, then it definitely reduces the logging.
I was going to add one more thing to it. One thing you should keep in mind is since X-Ray does sample, you should keep that in mind for things where you have logging that's necessary for compliance reasons or other things. So it's not necessarily a replacement there. But as Alan mentioned, if you've just got operational logging that you're doing, you can definitely see use cases, or I can definitely see use cases where you could replace one for the other.
It definitely doesn't totally replace logging. We still have plenty of logging.
Big thumbs up to you guys because it costs us probably 10 times more to maintain our Elk stack on awesome. AWS, so this will definitely help.
Thank you very much. All right, I'll take one over there.
Yeah, I was just going to say, if you did have something like PHP, and maybe I misunderstood something, can you, from PHP or one of these other kind of things like Ruby or whatever, can you say, hey, X-Ray, I'm doing this now?
Yeah, so since we don't have PHP or Ruby SDK today, you can actually directly send data using our APIs. So the AWS SDKs have language-specific, if you will, APIs. So you can use the PHP SDK for AWS and send data into X-Ray using the raw data format that we support. The SDKs just make it easier.
And the SDK, the ones, they're the ones that do UDP?
So the X-Ray SDKs do UDP. The AWS SDKs talk over HTTPS directly to the backend. So in that case, you don't have to use the daemon.
All right, I missed it. Thanks.
OK, perfect. Thank you. I'll go on that side.
So I think I saw a slide, let me know if I did, saying that you can get some utility from X-Ray without instrumenting any code, and if so, what?
So that is holds true for Lambda specifically. So in Lambda, without doing anything, by simply checking a checkbox in the console or setting the active tracing configuration, you can get the wrapper timing around your function. What you have to do to get the outbound calls that your function makes is integrate the SDK into your application. So without any changes in Lambda, you get the Lambda service portion as well as the wrapper portion for the function.
Thanks.
All right, I'll hop over here.
I have two questions. Are we getting billed for traffic which is going to, which is sent to X-ray service?
So the same data transfer charges apply. So when you're within a region, you're not, so because it's going from EC2.
Okay, yeah.
But if you're doing cross-region, then everything's the same.
And second question, are there any performance penalties, if any?
From a performance perspective, we've done our best. Everything that X-Ray does happens asynchronously. So the structured logs that are collected by the SDK happen on a separate thread. The SDK talks to the daemon over UDP, and then the daemon does the processing where you can control, in essence, the memory that you allocate. In practice, we've seen it take between 3 to 5% memory and CPU. However, if you wanted to do, if I wrote an app that just returned 200 OK, you can see a 200 or 300% overhead. But I've had 0 customers in the year that we've been out complain about performance. So I'm fairly confident that you're not going to run into it.
Great, thank you.
Thank you. All right, let's.
How hard is it to instrument like third-party like model view controller stuff, and stuff like that, like with the X-ray stuff?
I would say that if you don't have the source code, it's fairly difficult today because we don't do bytecode rewriting or use the profilers for the various languages or profiling APIs. But it is something that we're looking into. So we're hoping that in the next year and a half, we can make that easier. All right.
Okay, actually, I have two questions here. So for the gentleman, he just said that after using the X-ray, the total cost get lower, right? So the comparison is made between X-ray and what? That's the first question. Okay, and the second question is that to this gentleman, that dear speaker, that I noticed that for most of the instrumentation method that you just showed, we have to do some code modification. And compared to some existing APM products like, third party like APP Dynamic or Dynatrace, basically they don't need user to do any modification. So do you have any improvement plan on that?
So I'll let Alan take the first question.
Say the performance question again.
Cost,
yeah.
Yeah, you say that after implementing X-ray, the cost get lower, right? The cost get lower. So
The cost for us of comparing different APM vendors to X-Ray, it was definitely a lot lower than the cost of compute versus 3 to 10 times the cost of compute. And for us, there's also a cost associated with how much time you spend debugging an issue versus finding it a lot quicker and moving with it.
Okay,
So those are the two costs that I kind of talked about there. Does that make sense?
So that's a labor cost, right?
There's a labor cost, but there's also we decided we wanted application performance monitoring. But with the cost being a lot lower with cloud-based pricing, it allowed us to effectively put it everywhere. So we didn't have to think as much about cost at that point.
Okay, I see, thanks.
All right, guys. On the second piece, so today, yes, you have to make code changes. Part of the reason we took that approach is we see X-Ray as a developer tool. We don't focus as much on the ops side of things. We really think that the value of X-Ray really shines when developers are annotating data. They're adding additional, in essence, business data into the traces. So that's part of the reason why we've taken that approach. In the future, you can definitely expect that we will do agent-based instrumentation, which is the automated instrumentation that you're talking about. But that's not something that's been our focus so far. So today you have to do the instrumentation manually. I'm going to take one more question, and then I'm just going to walk out and hang out. So anybody who has a question, I promise I will stay as long as I need to answer those questions. But because we have to turn the room for the next session, I'm going to take one more here and then hop outside.
Guys, those are in line. Please stay there or just come up and grab your slices.
All right.
How do different services know that they're part of the same trace?
So if you looked at on the presentation, I talked about trace context and propagation. So what the SDKs essentially do is they generate a request ID, and then they propagate that over HTTP, or if you're in a queue, over the queue or message metadata, if you will. And that's how we connect the traces. So we're essentially propagating a specific ID as well as parent information so that we can build the graph for you.
Gotcha.
Perfect. All right, so with that, thank you guys very much. I greatly appreciate you guys hanging around and letting us win over beer. So thank you guys. And I want to give a round of applause to you guys.